1, 3, which is real numbers. And the number line. Hey, we're keeping up. Okay. Real numbers and the number line. So there is a button that I need you all to find on your calculator. So get your calculator out for me right now, if you have it. Which, side note, you should always have it. Okay? Always take it with you to class because you're going to use it all the time. Yes?
Should I sharpen my pencil?
Yes, you may. So on your calculator, there is a square root button. Do you all see your square root button on your calculator? That is this button. On this calculator, okay, it's not keeping up. Man. Okay, well, we'll see. On this calculator, actually, we're just going to switch because it's not going to keep up. So on the TI-30 that I feel like most people have, you have to push to make it a square root. You have to push second. And then if you look here, it's kind of hard to see right now, right here on that X squared key, the blue button below it, the blue symbol below it is the square root. Okay? So get familiar with that. If you can't find it on your calculator right now, let me know and I will help you find it. But you're going to use that button a lot in the next few days here, so make sure you know where it is. So that's a square root, okay? That's the square root button. Anyone know what a square root does? Or what a square root is? It is multiplication. It's multiplication of itself, essentially, right? So we would say A is the square root of B if A squared equals B. Okay, A is the square root of B if A squared equals B. So for instance, 7 squared is 49, right? That means that the square root of 49 is what? 7, right? So it's whatever number times itself gets you the number under your symbol, okay? So the square root of 49 would be 7. Okay? So there's some symbols and names that go along with this. If I have this set up, okay, the whole thing is your radical. But then you have your radical symbol is just this square root sign. So this is your radical symbol. Does anyone know what the number under the symbol is called? It's a weird word. It's not a word you maybe have seen before. I don't know. It's called a radicand. Okay, so that's the different parts of it that you're going to be working with. Let's plug a few of these into your calculator. Actually, before you plug it into your calculator, I want to know if you can figure it out without your calculator, because a lot of these you probably know without your calculator. But then we can always double check it with the calculator. So, for instance, example 1 here. Let's say I want to know what is the square root of 81. Anyone know that off the top of your head? 9, right? The square root of 81 is 9 because 9 times 9 is 81. Then we get a little fancier and we do the square root of a fraction. The square root of 9 over 16. Do you know how to figure that out? 3 and 4, right? So you figure out, rather than think of it as 9/16 and having to think what times itself is 9/16, it's a little easier if you just think what is the square root of the top number, the numerator, and what is the square root of the bottom number, your denominator. Okay, so the square root of 9 is 3. The square root of 16 is 4. So it's more like we thought of it as the square root of 9 over the square root of 16. Okay, but this would be your answer for that. Okay, so let's get a little bigger here. What about the square root of 100 over 49? What's the square root of 100? 10, right? So square root of 100 is 10. Square root of 49 is 7. So you get 10 over 7. Okay. Okay, last one. And this one could be really simple or it could confuse just because I don't know if you know what they are. What's the square root of 1? 1, right? 1 times 1 is 1. So the square root of 1 is 1. What's the square root of 121? 11. So that would be your answer. Okay. Any questions on that so far? Okay, then the second thing we're going to do, this is example 2. Is we're going to estimate. That is not an E. We're going to estimate some square roots, okay? So don't plug this into your calculator. If I said, what is the square root of 386? Okay, I want you to think about how high could you go with square roots? Do you know what the square root of 400 is? Not 50.
4?
Square root of 400. What times itself is 4?
2.
2, okay.
100.
20. It's 20. Because 20 times 20, right? You take the 2 zeros, you get 400. So the square root of 400 is 20. So this is pretty close to the number 20. Is it more or less than 20? This is going to be less than 20, because if the square root of 400 is 20, then the square root of 386 would be less than that, right? And this one you probably don't know, but 19 squared is 361. I don't know that one off the top of my head, so I definitely don't expect you to know it off the top of your head. But if 19 squared is 361 and 20 squared is 400, then somewhere between there, 361 is less than this, 400 is more than that. So the number, the square root of 386, has to be between 19 and 20, right? Do you think it's closer to 19 or closer to 20, based on the fact that this is 361, this is 400, this is 386? Is that 386 closer to 400 or closer to 361? It's closer to 400, right? So if we had to approximate this, we'd say it's close to 20. You know how to do approximately? That's the double tilde. Okay, that means it's not 20, but it's close to 20. We're approximating. Okay, and if you're not sure on something like that, you take your calculator and you just plug them in. So say we had no idea. Well, 18 squared is 324. 19 squared is 361. 20 squared is 400. So until you find the two numbers that wrap around it, then you know it's a number in between there. Okay? So what if I said, well, let's do this first. Plug the square root of 386 into your calculator. The square root of 386. Kennedy, what are you watching? She's watching you instead of me. Put your iPad away. You don't need your iPad right now. Plug the square root of 386 in. What do you get? 19.6. If you're rounding it to the nearest tenth, square root of 386, right? So here's your number. That would be 19.6. Let me just tell you real quick where a lot of people have some confusion on rounding, okay? Sometimes people want to say this is 19.7 because that 6 makes the 4 a 5, and the 5 makes the 6 a 7 then. That is not correct, okay? You only look at the number where you want to round. So if I want to round to the nearest tenth, I look at the number right behind it, and if that number bumps it up, we bump it up. This 4 doesn't bump it up, right? So we just leave it at 19.6. So the actual, and still this is technically still an assumption or a approximation, but the actual amount would be about 19.6. Yeah.
But why?
Why what?
Why do you have to do it from the 10th, not all the way through?
I'm just saying round to the nearest tenth right now. So sometimes they might ask you to round somewhere else, right? But if I want to know what is this number to the nearest tenth, that means I'm looking at my 10th spot. I want to know what number should go here. And the way you determine what number should go in a place is by looking at the number directly behind it, not several numbers behind it, right? Because we don't want to round and then round again. We want to round one time. So if we're going to round this one time, that 6 has a 4 behind it. 4 doesn't bump it up, so it just stays a 6. That makes sense? So just look at your one number. You need to go one place behind that. That's it. So like if I had 20.475 to the nearest tenth, what would you round that to? 20.5, because here's your 4. The number behind it bumps it up, right? Whereas if I did 20.435, here's your tenth. The number behind it doesn't bump it up, okay? So to the nearest tenth, this would be 20.4. To the nearest tenth, this would be 20.5, okay? Okay, let's do one more estimating and then we'll keep going. Can you estimate for me the square root of, let's do 216. Okay, so here's what I would do if I were you. When I ask you to estimate, I would start plugging in numbers. So the square root of 216, what is 10 squared? That's 100, so we're really not close. So let's try 15 squared. That's 225. That's pretty close, right? So 15 squared is 225. What direction do we have to go? Higher or lower? If we're trying to get to 216 and we're at 225, we need to go lower, right? So we're going to try 14 squared. And 14 squared gives you the number 196, okay? So if you look at those numbers, you have 216. This is 225, this is 196. Which of these two is it going to be closer to?
56.
Which one?
196.
No, the 225, right? This is 9 units away from 216 to 225. This is 20 units away. So this one's going to be the closer one. So we're going to say this is approximately 15, okay? But what's the exact, not exact, what's the rounded to the nearest tenth answer? So if you plug it into your calculator, square root of 216, what do you get? 14.7. Okay, so we know it's somewhere around 15. If we want to be a little more precise, 14.7 would be to the nearest 10. Questions on that? Okay. We're going to draw a picture. Kind of. We're going to talk about a bunch of different types of numbers, sets of numbers. So a set is just a collection of numbers, and then within that set, you'll have what's called an element of your set, which is one of the bunch of numbers you have, okay? So what we're going to talk about are rational numbers and irrational numbers, all of which fall under the realm of real numbers, okay? We're not doing any imaginary numbers in Algebra 1A. You will get there if you ever take, I don't know where they start talking imaginary. Algebra 2? Yeah, she's maybe not there yet. So these are all real numbers, okay? They all fall under that realm. But then there is rational, and there is irrational. And our irrational category is very small, so you don't need to make that a huge thing. Rational numbers can be written as a fraction. Okay, rational can be written as a fraction. Irrational can't be written as a fraction. Okay, so in the realm of rational numbers, okay, anything that you can do as A over B is considered rational. Okay, but then there are these like 3 subcategories to rational numbers. So there are the natural numbers, there are whole numbers, and there are integers. Okay? Does anyone know what any of those are? Yeah, Ryan. Well, numbers with exponents can be whole numbers once you plug it in. Not a fraction. Yep. None of these will look like a fraction. They can all be made a fraction though, right? Like the number 2 doesn't look like a fraction, but can you make it a fraction? 2 over what? 2 over 1 would make it a fraction, right? So that makes it a rational number. Okay, so here's how I tell people to remember it. The natural numbers are if you think to yourself, if I were naturally going to start counting right now, what would I do? Where would I start?
0.
Oh, that's not where I start. I start at 1. Okay, so my natural inclination to count is 1, 2, 3, 4, 5, right? So those are the natural numbers. Natural numbers are 1, 2, 3, and the list just keeps going as high as you can go. Okay, those are natural numbers. Whole numbers add 1 number to that list. Anyone know what it is? The one you first said. 0. Okay, and the way I tell people to remember that is whole numbers kind of has a 0 right in the middle of it, right? So whole numbers are 0, 1, 2, 3, and just keep going, okay? Does anyone know what gets added to that list for integers? Yeah. The negatives. So integers go in both directions forever. So -2, -1, 0, 1, 2, and they just keep going in those directions, okay? No decimals, just the whole numbers, but positive and negative, okay? Questions on that? Okay, so just to give you a few examples of both these types, okay? So right now I'm talking the whole rational category. A few things to look out for. You can have a terminating decimal. Anyone know what a terminating decimal is? What does it mean to terminate? Stops, right? A terminating decimal stops because a number like 5.45, the rule is if it's going to be rational, we have to be able to write it as a fraction. Well, 5.45 you can write as 5 and 45 hundredths, right? So that works as a rational number. Okay. You can have, a repeating decimal. So a repeating decimal would be something like 2.3333 or 2.3 repeating is another way you could write that, right? 2.33333 is 2 1/3, same thing, which is a fraction, which is why we can do it. Okay, so a repeating decimal will always be something we can turn into a fraction. All right. And then you can do some square roots as well. Not all square roots. A lot of them don't work. But like the square root of 4 is a rational number. Why? What is the square root of 4? 2. Because it's 2, right? The square root of 16 is a rational number because it's really the number 4. Okay? So that's rational numbers. Irrational numbers are numbers that don't fall into that. So like the number 0.1010010001 and so on and so forth. It has a pattern, but you cannot write it as a fraction. Okay, so that's irrational. The number pi is irrational. Why do you suppose pi is irrational? Ryan? It's never ending. It's just going to keep going. We can't write it as a fraction. We can round it as a fraction, but we cannot write the number pi as a fraction because it is 3.14159 da 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 da. Okay? And then the square root of 3. If you were to plug that into your calculator, you would get this number. 1.73205080, and it just keeps going, okay? So square root of 3 is not rational, that's irrational. Square root of 4 is rational, right? If it turns into a whole number, it's rational. If it doesn't, it's irrational, okay? Questions on that? Okay, so tell me, based on that list, hopefully you have it in front of you still, because I'm going to keep moving up. I can jump back if I need to. Which category does this fit into? So example 3 here. We're going to say which subcategory? Does it fit into? So for instance, if I gave you the number 15, tell me the different categories that work there. Natural works. And I'll just tell you right now, if you want to shorten these, you are welcome to. Some of them make sense for their variable that goes with it, and some of them are like, where in the world did they come up with that? But you're welcome to do this if you want. So natural, we shorten with just a capital N. Okay, so it is natural. I think you said whole also, right? Okay, whole numbers also work. We do with a capital W. Okay, does this fit into any of the other categories? It does. It's an integer, right? These are integers, and this is one that doesn't make sense. Integers we do with a capital Z. I don't know why. I guess I is just a weird one because it's irrational, so we don't want to think irrational, so they threw a Z in there. And then technically it falls under the category of rational numbers because we can write it as a fraction, and again, this is a weird one. That one is Q. So if you wanted to write NWZQ instead of natural, whole, integer, rational, technically you could. If you're more comfortable just writing the word out, write the word out. I like the word better personally, but that's up to you. Okay, so there's one. What if I gave you the number negative 1.4583? Is it an integer? Can you have decimals with integers?
Oh, no, it's irrational.
But it's not irrational. This is a terminating decimal, right? It's a decimal that ends. I didn't put the ... behind it. So if the decimal ends, because it's a terminating decimal, it is rational. Okay, which if you want to call it Q, you could. But the reason being, it's a terminating decimal. Okay. Last one of these. The square root of 57. What category would that fall into? And if you don't know the square root of 57, plug it into your calculator and see, is it rational? Is it irrational? What would it be? What? Plug it into your calculator. Square root of 57. Does it end?
No. Yeah, it doesn't.
Well, your calculator might make it seem like it does. It actually is not going to end. It's just that your calculator doesn't give you any further numbers than that. But if it goes all the way to the end of your screen like that, it doesn't end. So this would be considered irrational. Pretty much anything that has a decimal point when you square root it is irrational. If it's a whole number, it's rational. So we would say it's irrational because it's not a perfect square. Okay, questions on that? All right.